Today's lesson will be discussing about the Pismoidal correction and critical curvature corrections. So these are the corrections that we need to apply in computing the volume of Earthworks. So for their learning outcomes, to be able to apply Pismoidal correction and curvature correction in computing the volume of Earthworks. Short recap from the previous discussion, earthwork is a process na ato-move ang atong mga sand or the and form rocks or a portion of the Earth's surface from one location to another location. So, will be reconfigure ang topography nato sa depending sa atong design or sa atong layout. So, earthwork activities include sa excavation or embankment or the cut and fill. When we say cut refers to the removal of the volume of earth from the grave. So, for illustration, for areas or elevation of the existing ground which is higher than our proposed elevation, in those areas we need to cut or we need to do an excavation. Then for the fill naman is the refers to the addition of the volume of the earth from the grade. Or if the existing ground elevation nato is lower than our proposed elevation, we need to embank sa atong mga sand or fill or sa atong portion of the earth's surface. Okay, then for cross-sectional area, so cross-sectional area is the initial step in computing our volume of earthwork. So this is an example sa atong cross-sectional in a top view perspective. So this line, mo ni atong center line sa atong road. Remember na if magkuha ta cross-sectional area, it should be perpendicular sa atong profile. In this case, sa atong center line sa atong road. Then, mo ni atong cross-sectional area. Assuming na making atong station 1, then our side views at station 1 is this one. So, in this case, na atong existing ground elevation, which is this one, is greater than sa atong proposed elevation. So, in this area, we need to cut atong paon ang atong mga sandary or informed rocks para ma-meet nato ang desired elevation. Then types of cross sections. So first is the level section. So level section, usually this is used when ang ating topography is level. Then three level section. So three levels, so three rod readings sa isa ka station. So we'll take rod readings sa atong center line, then two rod readings sa both sides, left and right sa ato ang intersection on the existing ground and the side slope or the slope state, left and right. Then sa 5-level section, may modification lang siya sa 3-level section. Sa 5 levels, so 5 red readings at this station. Magkuha ta og red readings sa ato center line sa ato road, then two red readings sa intersection sa ato ang existing ground at the proposed elevation or the slope state, then also sa edge sa ato ang base. So, assuming kani ang atong base with sa base or example mo ni ang kalsada nato, ang endpoint niya ana, ang edge niya may tupaon. Vertical distance niya ang iyaha mo ng 5-level section. So, 5 rod readings. So, sa cycling section naman, so, atong isa ka station, we have the cut, we have portion na to cut, or also we have a portion that we need to do a fill or sa mag-imbang sa niya. Then, for computing the volume of earthworks, we have these two formula using the end area method and the Pismoidal method. So, sa Pismoidal method, which we consider ang ato ang cross-section sa cross-sectional area sa midsection or sa distance between sa atong two stations. Assuming natin station 0 nga rin, then station 1, so ang midsection na niya ato i-consider. So, ang atong ma-compute na elevation is more accurate than the end area method. Okay, sa atong end area method, we'll just get the average sa cross-sectional area sa two station and i-multiply natin sa iya horizontal distance or sa distance sa ato profile. Pero sa kanito sa end area method, ang atong topography in between niya, kay wala na ito i-consider. Since kanina naman ato, first station natin cross-sectional area, then sa second station natin cross-sectional area. wala na kong sir. Pero this seems due to simple sa simplicity sa iya formula, usually sa contractors mo niya gigamit. However, kung mag-compute ka og end area method, diha na nato mag-apply ka og pismodal correction. So, mo natin discuss karon. Sa pismodal correction, it is always subtracted sa atong computed volume sa area. So volume corrected is equal sa volume sa computed method using the end area method minus sa ato ang volume computed for the pismoidal correction. So atong formula for pismoidal correction is equals to L over 12. So ang L is the horizontal distance between two stations. Then C1, which is the vertical distance sa ato ang from the center line to the existing ground surface sa station 1 or on the first station. Then C2 is the vertical distance on the second station from the center line to the existing ground surface. Then D1 is the horizontal distance from left na slope state to the right slope state. Then sa D2 naman for the second station. Okay? Then second correction nato nga kinahanglan i-consider is the curvature correction. So the curvature correction, sabi no, di ba, ato figure in computing the end area method and this one end area of this model, we consider nato nga straight line lang ang first station and the second station. Same with the pismoidal formula, straight line lang ang distance between two stations. However, in reality, naman tayo mga curve sa karsada. So, in that case, kung distance natin between two stations is along sa atong curve, then we need to apply curvature correction. So, for the curvature correction, we have this one. L is the distance between two stations over 2r. So, ang r nato is the radius of the curve, which was discussed na sa atong horizontal and vertical curve and how to compute the radius of the curve. Then AS1 is the surface of the previous station. So, mo ni atong AS, our surface area. Surface area is different sa atong cross-sectional area. Then E1 is the distance from the previous profile of the center of the gravity to the horizontal alignment. So, ang E1 is the horizontal distance sa ato ang centroid. Then AS2, for the second station naman, then E2, this horizontal distance sa ato ang centroid from the center point or the center line. Okay. So, ang AS2, remember, nag-different siya sa cross-sectional area. Ang atong AS2, muna siya ang surface of the station. Para ma-determine nato ang surface of the station, matadaan na sa cross-section notes or level notes na we have the data ng X and Y or the horizontal and the vertical distance at the center line. Sa kanya siya is the base of the base nato or the road width, for example, then this is the side slope. So, para makuha na po ang cross-sectional area, ato lang siya i-determine kung from the center line, asa ang dako of surface area. If the left side ba or right side. So, kung mahuman na nato og plot, ma-determine na nato kung asa ang greater of area, surface area, nadto ang atong location sa ato ang surface of the station. So, in this case, sa left side sa atong from this point, which is our center point, na ang nari sa left side. So, on surface area, we have this computed cross-section area for this station. I-subtract nato sa ato ang A1, which is this first triangle nato, area of the first triangle plus area of the second triangle. Then, mura na nato siya, i-times 2, ato imagine na ato siyang i-fold. Naka-mirror ang diri sa left side. So, ang excess ana, mo nang ato ang surface of the first station. Okay. Then, ang sa E naman, we have this one, AS, which is this one. Then, ang E, which is the distance of the profile center of gravity to the horizontal alignment, mo na po ato i-determine. To determine sa E, it is 1/3 sa ato ang horizontal distance between two slope state. So, kani atong horizontal distance from endpoint sa atong slope state, then sa horizontal distance from the endpoint sa ato ang on the right side naman sa slope state. So, 1/3 ana is our distance of the center of the gravity to the horizontal alignment. So, ang atong E is negative if the excess area is towards the center of the curve. Then, sa atong E is positive naman if the excess area is away from the center of the curve. So, yan ang negative, and why is it positive man? Imagine mo ang ato ang top view sa ato ang profile sa ato station. We have this one, station 1, then station 2. Then, ang pagkuha nato sa horizontal distance or the L nato is always the center line. Sa atong road, railways, mo siya. So, assuming natay distance ani between two station ang X. But for some cases, kung nato sa curvature, makahinani ka. Since ang atong L is along sa ato profile, distance na sa along profile, kung we have this distance X, so ang atong distance niya rin is X side between two stations. So, station 1 then station 2. So, kung assuming ang atong curve is to the left siya, station 1, kadong ka natin sa left, then, ang kanin nga area, kung natay distance na rin nga X side, so kanin siya nga area, na-compress siya. So, muna tagmin na, assuming natay distance 1 nga rin, then ang nga rin, na 0.8 na lang. So, from our area nga formula, ang nga rin nga portion na overestimate na to, ang na-compute na to nga area. So, in that case, negative ang atong E. So, we will negative sa ato ang formula. Ato ba ang negative? So, ang atong excess area is greater na ang atong computed area using the end area and Pismidal formula is greater kaysa sa actual. Then, for areas naman na away sa ato ang center sa curve, for this one, we have 1 meter kunahay nga rin ang distance. So, ang nga rin, na-stretch siya. So, natay kunahay, nahimo na siyang 1.2. So, for this case, na-underestimate po nato ang ato ang na-compute na area. In that case, ato paanan siya o positive ang atong E. Sa kung away ang ato ang surface area from the center of the curve. Okay? Okay. I think that will be all in computing the curvature correction. So, do you have any question before we proceed sa ato ang sample problem? Wala?
Not so far, ma'am.
Okay, proceed to sa sample problem, ha? So, sample problem number 1. Given the cross-section node of an earthwork between station 4 plus 00 and station 4 plus 100, assume both sides to have same side slope and width of the base. So, we are not given mo na ito. Numerator na to is the x, then the denominator is the y. So, mo na itong center for station 4 plus 00, then sa left na to, then right. Then we'll have given sad ang atong cross-sectional area for station 1 and then station 2. So the problem is we are required to compute the volume between station 4 plus 000 and 4 plus 100 using end area method with this model correction. In that case, so ato sa i-plot ang station 4 plus 00. So from the center, natin 0, this 1x, then ang atong y is, or the vertical distance is 1.5. Then for the atong width sa ang atong base, from center point to the left na end point is 1/2 sa ato ang base. Or for example, assuming na natin kalsada, so 1/2 siya sa ato ang road sa width sa road for the left side and same with the right side. Then, for the left, ang atong x is 6.5. Dahil siya, from the center point to horizontal distance ta to the left na 6.5. Then, ang atong vertical distance is 2.3. So, somewhere dali ang atong slope state. So, mo ni atong side slope. Then, on the right side naman, from the center point, padong nato sa right, we have 4.5. Then, ang pa-upward na to na vertical distance is 1.0. Since positive man siya, so, ang atong existing ground is nasa babaw. So, for this case, we will have an i-excavate na to ang existing ground na to meet ang ato ang topography, desired topography or desired elevation. Okay mo na to, illustration for station 4 plus 000. Then for station 4 plus 100, so we have 0, then ang vertical distance is 1.2, positive 1.2, then distance sa ato ang slope base, 1 half, b over 2 for the from the center point to the end point sa ato ang base. On the left side, same with the right side. Then, for the left side, natay distance atong slope stake na 6 meters. Gikan sa center point to the left side na horizontal distance. And for our vertical distance is positive 2. So, mo ni atong side slope. Then, sa right side naman, natay 6.9 from the center point to the right side. Horizontal distance and vertical distance is positive 2.6. So, may mana siya figure. So, i-connect lang ni nato diha para makuha nato ang existing ground surface na to. Okay, so this is our illustration for station 4 plus 4 plus 100. So, we're asked to compute the volume between two stations with the prismoidal correction. So, na naman tayo, this is our formula for the volume using end area method. So, we have area of cross-sectional area of the first station, which is given for 13.1625. Then area for the second station is equals to 14.64 square meters. Then length nato sa ato ang distance between two stations, which is 4,100 minus 4,000 equals to 100. So, ang atong makompute na volume using end area is equals to, pwede ba natin makompute?
$1390.125, ma'am.
Okay. Okay, correct. So, 1,390.125 square meter, ay, cubic meters. Sorry. Then, sa atong, we'll proceed na sa ato ang computation using the prismoidal correction. So, we have this formula. So, L is the distance between two stations, which is equals to 100. Atong C1 is the vertical distance sa ato ang center. So, for station 4 plus 00, natay 1.5. Then, for the second station is station 4 plus 100, ang atong vertical distance is 1.2. Ito lang siya i-substitute in the formula. Then, for B1, the B1 is the horizontal distance from the left slope state to the right. So, 6.5 plus 14.5, which is 10.95. So, math of B1. Then, for our B2, is 6 plus 6.9. So, ato yung substitute diha sa atong formula that will give us an answer of muna natong computed volume for the prismoidal correction. Okay, nag-compute ba?
Negative 4.875, ma'am.
Okay, that's correct. So, ato volume of The cosmoidal correction is negative 4.875. Then again, our computed volume for the corrected volume is volume sa atong end area minus sa volume sa atong cosmoidal correction. Since negative man siya, ato na po siya substitute sa formula. So, for the corrected volume is equals to 1390.125 minus negative 4.875.
Six, 1390 point.
So, for our computed volume, same bataw na ang answer, which is equals to 1395 cubic meters. Okay? So, mo na ni atong volume between these two stations na naka-apply ni ka of Prismidal correction. Okay? Then, proceed na ta. Do you have any question? Sa atong sample problem 1?
Yes, ma'am. Nga naman lahi ang mugawas, ma'am, dun sa VE, ma'am.
VE?
Like 13.625
Wait
plus
lang. Okay.
14.6.
13.625 plus 14.64 equals times 100. 100 ato, horizontal distance. Then divide
1413.25 mugawas sa kalki, ma'am.
13.625 plus 4. 13.1625 plus 14.64 times 100 divided by 2. 1392. Ay, sorry for this one. The area for the first section, cross-sectional cross-sectional area for the first station is 13.1625. This one on the left side.
Okay, ma'am.
Do you have any other question? Right na?
Wala na, ma'am.
Okay, let's proceed to sample problem number 2. For sample problem number 2, we have a given cross-section note of earthwork on a rolling terrain. So, then the width of the road is 12 meters and the side slope is 2.5:1. So we also have a given cross-sectional area na sa first and the second station. Then, first problem is required to compute the volume using an area method with cosmoidal correction. Then for the second, we're asked to compute the volume using the end area with curvature correction if the road is on the curves is on the 6-degree curve which turns to the right with the given cross sections. So first, ato sang kuhaon ang first problem is the volume and area with cosmoidal correction. So for this one, ato siya i-plot ang station 5 plus 000 and station 5 plus 030. Okay? Then sa atong center, we have 0, then vertical distance is positive 5, so upward. Then sa atong left, from the center point to the left side, we have the horizontal distance na 31 meters. Then ang atong vertical distance is 10 meters. So ang atong side slope is the intersection sa atong slope stake to the end sa atong base. Then ang atong base ni I is 12 meters. So from center point to the left, we have 6 meters. Then to the right, we also have 6 meters. So total base nato or width sa road is 12 meters. Then sa right, we have this horizontal distance is 13.5, then vertical distance is positive 3. So we will have this diagram for station 5 plus 000. Then station 5 plus 020, 0 ang ato ang center, then upward, lapon ka, positive 7. Then for the horizontal distance for our slope state, we have 41. Then vertical distance is 14. This one. Then this one naman sa atong x is 17.5.25. Then ang vertical distance is 4.5. Okay. Sa atong volume, using the end area method, we have this formula. Area sa cross-sectional area sa first station, which is given, that is equals to 150.25. Then cross-sectional area for the second station, that is equals to 259.375 square meters. Then L, distance between two stations, which is 5,020 minus 5,000 divided by 2. So ang atong volume, using the end area method, is equals to
4,096.25, ma'am.
okay.
25.
So correct. That is our volume. 4,096.25 cubic meters. Then for the prismoidal correction, again, we have this formula. So, ato lang siya is substitute. So, ang atong distance between two stations is 20, then over 12, constant. Then, for our C1, which is the vertical distance from our proposed elevation to our existing elevation, na equals to 5 for the first station. Then, sa ato second station, it equals to 7, so minus 7. Then horizontal distance nato, D1 for the first station, which is 20, which is this one, 31 plus 13.5. That will give us 44.5 for this D1. For the D2 naman, 41, this one, plus 17.25. That will give us 58.25. So our volume sa atong prismoidal correction is equals to
45.83, ma'am.
okay, 45.83 cubic meters, so positive. So to compute atong volume by end area with prismoidal correction, again, volume sa end area na compute natin which is 4,096.25 minus positive 45.83 cubic meters. So ang atong volume using by end area with prismoidal correction is equals to
4,050.41.7. 42.
4,050.42 cubic meters. Okay? So, muna na to sa ato problem A. Sample problem 2.A. Then sa 2.B, we're asked to compute using end area with the curvature correction if the with curvature correction if the road is on 63 curve, which turns to the right with a given cross section. So, assuming this is our station 5 plus 00. Then turn to the right man ang atong kurbada so kadong tangaring. Then, mo niya to second station. So, for station, cross-sectional area sa atong first station, 150.25. Then, cross-sectional area sa atong second station, we have 259.375 square meters. So, ang atong formula for the curvature correction, we have this L over 2R AS1 E1 plus AS2 E2. So, first, we'll solve for AS1. So, yung AS1 nato, kung after nato siya ma-plot, diba na-plot na natin siya sa sample 2.A. So, mag-determine na nato ang AS1 given atong illustration. So, from this center point, kani sa ato, ay from this area, atong cross-sectional area, ang atong left side is, ang atong surface area for the left side is greater than the surface area sa atong right side. So, atong i-compute ang area sa atong right side, then ato lang si Jang, murag ato siyang i-mirror, i-times 2. Then, so, we have the given cross-sectional area, ang access ato, ma-or surface area. So, ang cross-sectional area na 150.25 minus triangle 1 nato ani is the base nato is 6 plus 7.5 which is 13.5. Then ang height nato is 5 over 2. So base times height over 2. Plus sa second triangle nato which is 6 times 3 over 2. Then aton siya times 2. Muna siya atong i-mirror. Ang atong right side to the left side times 2. Then ang axis ana mao ang atong surface area. So we have 150.25 minus dito siya 5 plus times 13.5 over 2 plus 3 times 6 over 2. Then i-times 2 na to which will give us 85.5. Sakto ba? Then after na nato makompute ni siya ang area, we'll subtract this one sa ato ang given na cross-sectional area for the first station. So, ang atong AS1 is 64.75 square meters. Okay? Then, sa atong E1, ito E1 is the 1/3 sa atong B1. So, ang E1 nato is equals to, ang B1 nato is this one. Natay 25 plus 6 plus 6 plus 7.5, that will give us 45.5. So, substitute lang nato 44.5 over 3, muna nato E1. Then, ang ato na lang ani to determine if positive ba to E1 or negative. So, kani man sa illustration, kani ang atong center line. Then, ang atong curve towards the right. So, ang atong center sa curve na ang somewhere here, then mo na ito radius. Na, radius. Since ang atong surface area, AS1 and AS2, kay naman away man sa curve, gikan sa center line, pagawas man siya, so we will have a positive na E. So, ang atong E, 44.5.3, that will give us 14.83 meters. So, positive siya, no, kay pagawas away from the center of the curve. Okay? Then, next, we'll compute the AS2 na sad and E2. So, for AS2, we have this one. We'll compute the area sa ato ang left side, then i-times 2 lang. Then, ang axis ana niya, mauna ang surface area. So, cross-sectional area, 259.3.75. Nangyari, atong substitute na rin. Then, ang atong triangle, 1, na this one, having a triangle, we have the base na 6 plus 11.5, then height is 7 over 2. So, base times height over 2. For triangle 1. For triangle 2, we have the base na 6 meters, then ang height nato is 4.5 over 2. Then, ato lang na siyang i-mirror to the left side nato, so times 2. Then, ang axis, again, is the surface area. So, that will give us 2.259.375 minus 147.75. So, AS2 is 111.625 square meters. Then, we'll proceed in computing sa E2 na pod. Sa E2, B2 over 3. So, ang atong distance to horizontal distance is 58.25 over 3. So, ang atong answer ana kay since sa second station na pod nato is away man gyapon siya sa center of curve ang atong surface area. So, positive gyapon. So, atong E is positive 19.42. Okay? So, sa atong formula, we have the L, which is distance between these two stations na 5 plus 000 and station 5 plus 020. Then, AS2, na na-compute na nato na 64.75 square meters. Then, E2 is 14.83. Then, AS2 na po na 111.625 square meters. Then, E2 is 19.45 meters. Sa atong R, muna ito natin i-compute. Since naman tayo namin nga formula sa atong horizontal curve na 1145.916 over D, which is ang D na to ang degree of curve. Since ang degree of curve is given na sa ito formula na 6 degrees, so ato lang siya is compute to solve the radius of the curve. So that will give us, ang atong radius of the curve is equals to, okay, 190.99. Okay? Then, so, nakuha na nato tanan unknown sa ato equation, sa ato formula. So, substitute na lang na nato. We have this 20 meters over 2 na times computed nato nga R, which is 190.99 meters. Then AS1, substitute na lang nato. E1, then AS2, and E2, which is 19.42. So, ang atong volume with curvature correction is equals to
163.78, ma'am.
okay, 163.78. Then, remember na ang atong formula for ang kaning curvature correction nato, it should be added sa ato ang computed volume. So, sa atong end area, na-compute na nato sa 2.8, that is equal to 4,096.25. So, ang atong computed corrected volume ay 4,096.25 plus sa ato ang computed na volume sa curvature correction. So, 4,096.25 plus 163.78 is equals to muna na atong computed na curvature correction.
4260.03, ma'am.
Okay. So, if to compute muna na atong volume of the curvature. Okay, do you have any questions? So, if wala na, proceed na ko sa matato discussion po. Discussion sa atong curvature correction and that is modal correction. So, for the announcement, natin assessment exam this Friday, May 27. So, ang topic for our assessment exam is lesson 3.1 and 3.2. So, computing sa volume, using an area desmoidal, and also sa atong correction. Natin i-discuss karon. Desmoidal correction and the curvature correction. Then, modular exam, that will be next Friday, June 3. Also, sa atong group project na-post na nako last week, last Wednesday. So, June 10 ato deadline ana. That will be next week, Friday, June 10. Okay? Also, mag-ask ko og to answer sa atong survey questionnaire, VMGO. So, this is the link for our VMGO. Then, please po pa-answer sa inyong parents na lang sa, you can use your Google account na lang para sa inyong parents sa pag-answer sa VMGO na survey questionnaire. This is the vision, mission, and goals of objectives sa BSU. Okay? Wala na, question?
Excuse me, ma'am. Pwede ba may mga yung copy ani nga presentation, ma'am?
Okay,
Or,
I'll post it later na lang.
okay, ma'am. Thank you.
Okay. So, since wala na, kasi mag-discuss na ko kadali sa atong project. So, the group project. Sa inyo, which is the offering number na 4020, i-divide mo into 3 groups. So, first 2 groups na 9 numbers, then third group is you have 8 numbers. Okay? So, sa ato ang assignment, for group 1, natin station, ang assignment niya is to lay out station 0 to station 400. So, kani siya, station 0 to station 400. Then for group 2, station 360 to station 760. This one. 360 padong nga rin sa 760. Then group 3, station 720 to station 1120. So, nari, dapita, station 760 padong sa endpoint sa circumferential road. Okay? Then, sa requirements na to sa PDF file na i-post, we're required to create a profile sa road. So, sa profile sa road, example ni siya, so, ang atong X is the distance or the horizontal distance along sa curve, then ang atong Y is the elevation. The next is the horizontal and or curve. So, for each group, you need to design at least 3 curves, horizontal or vertical. Depende na ninyo. And then, remember na atong horizontal and vertical curve, dapat nani ng mga elements as well as other elements na nasa vertical curve, na point of curvature, point of tangency, point of intersection, deflection, basis of the curve, tangent, distance, external distance, and other elements. So, at least 3 curves man. So, for the first group, since you're assigned sa station 0 to station 400, so we can narrate to here. We can pwede na to, paananin mo, ang inyong first curve is this one, then second curve, then kani ang inyong third curve, doon sa station 400. Para sa inyong item sa vertical curve. Then for group 2, station 300 to station 360 to 760, so pwede ka nga rin. Muna yung first curve, then yung second curve, then muna yung third curve. Then for group 3, station 720 to station 1120, you can use this curve. First curve, muna yung first curve, then second curve, you can have this one. First curve, second curve, then third curve. Okay? Muna sa inyong horizontal and vertical curve. Then next is your design as to have a map of the proposed road design. So, proposed road design from first station to end station, and also para makita nato ang inyong curve, so hindi siya abrupt, gradual ang iyang changes. Since remember na yung design sa curve dapat kung siya, consider nato nga makita siya sa kung road ang atong i-design, magkuha na itong mga vehicles, makita siya, or to avoid sa mga accidents. So, kana lang, para makita lang nato ang inyong design sa inyong curve. Then lastly, you're asked to compute sa volume of earthwork. So for volume of earthwork, you can use an area method or the Pismolden formula. Depende na lang sa inyong nasabutan sa per group. So, since naman may 9 members or 8 to 9 members per group, pwede na siguro ninyo i-divide na lang. Then you consolidate na lang. Divide para first member, you can compute the station 0 to station 60. Then second member, station 60 to station 120. Then you consolidate na lang ninyo para di na have yung workload. Okay? So, malapod to sa inyong project. I think that would be all na. Do you have any questions sa inyong project? Wala. Okay. Kung wala, I think mo na to siya karon, no? For today's discussion. Okay, if you don't have any question, you can leave na sa meeting. Since it's already 9:49 naman sad. Okay.
Thank you, ma'am.
Okay.